Hello, and welcome to Altium Live 2022. It's a real pleasure to have you here. My name is John Watson. I'm going to be a presenter here, and we are going to be talking about coping with design challenges with an intelligent library. Now, before I get into that, I just wanted to commend you on on being here, taking the steps that it took for you to kind of pull yourself away from maybe projects or different things like that, and the jobs that we're all doing, right? And kind of pull yourself away and work on yourself. This in the next few days. If you haven't participated in an Altium Live event in the past, I can tell you that this is going to be. I don't use these words lightly, but it's going to be a life-changing experience for you. The chance to learn from industry experts that are the top notch and to be able to go back to your jobs as better designers, better engineers is really key here. And that's our main focus is to connect as designers and learn and kind of work on ourselves, okay? So this is going to be a great event for you for the next few days. So take the time and effort to get involve yourself with as many of the presentations as you can, and to learn from these great leaders. So um, I wanted to introduce myself. My name is John Watson. If you don't know who I am, consider yourself fortunate. No, just kidding. Um, I am a designer of 42 years in the field of electronics, 22 in the PCB area. I've served with the U.S. Army in the military intelligence area, and I've worked with several Fortune 500 companies. I am also a certified IPC designer. Now, in my spare time, I also am a writer for several PCB publications, the author of 2 books on PCB data management, an international speaker. I work with the Delft Hyperloop team in the Netherlands, which is always fun. And I'm also an instructor at the College of Engineering in Manila, Philippines, as a guest speaker each year. I'm also a board member for the Printed Circuit Engineering Association, the PCEA, in their Advanced Educational Committee. And lastly, I'm also a professor at Palomar College of San Marcos, where I teach PCB design, basics and advanced. So that's a little bit of a, a view of who I am. And what we're going to be talking about is we are going to be looking at specifically several design challenges that we have as PCB designers and things that we deal with probably on a daily basis. But we're going to be looking at this a little bit differently. What we're going to be doing is we are going to be looking at how we can use our library to solve those issues and solve those challenges that we face. One of the most important resources that you have in your company, and I can say this without hesitation, is that the most important resource in your company is your component library. Every single PCB starts and it will end in that library. And those components are the main resources that you have to build everything in that company, all right? So there are what's called parent and child relationships. Now, this is a little bit of a review here. I'm sure you're aware of this. But there are parent and child relationships in the entire PCB design process, where you have the library, you have a schematic, the printed circuit board, you then have from that your Gerbers, your data, your BOM, things like that. Now, the way that you need to look at this is that each one of these, some of these are parents and some of them are children or child documents. For example, your schematic is a parent of your PCB. That's the source document for your printed circuit board. From that schematic, inside that schematic, I should say, is all the items that you need as in the way of components and things like that, to then move that process into your printed circuit board, and then also then filter that into the fabrication data, the Gerbers, different things like that. We also then we have the documents of assembly data. We have the printed circuit board then as a parent and of the child of the assembly. The schematic is a parent of the document, the child document, I should say, of the BOM. Now, this is really something we have to look at first off, because understanding the source document involves then the child documents. Now, the rule would be this, is that you do not change just the child document. So let me give you an example. I would not go into my BOM and just make changes on my BOM without making those changes on the parent document, which is what? The schematic. So it's very important to understand that and to keep this in mind and always kind of look at, so, okay, is this first off, is this a parent, or I'm sorry, is this a child document? And if it is, then what is the source or the parent document for this? Now, I bring this up is because even though documents may be both a parent and a child, there's only one document that is a parent, all right? And that is your library. Everything begins in your library, and that's those sources and the components. And the old adage of garbage in, garbage out is so true here. If you begin your design with bad components, or as we're going to see, incomplete components more likely, then what you're going to do is you're actually going to kind of have issues and problems. Now, I'm going to say something here that may not be a shock to some, but shock to others, is that if you are facing challenges in your PCB design, it's most likely because of issues in your library. All right, let me say that again. If you have problems and challenges in your PCB design process, then most likely it's because of issues in your library itself. All right. Now, we are actually going to be looking at, first off, in this presentation is where things should be stored, what you are storing in that location, and then also how to load that library up. All right. And by those three steps, we are going to then be able to have a strong resource for us to face and look at any challenges that are coming up in our PCB design. And we are going to be looking at specifically how to look at our library in a way where we can then find the answers of problems and issues and things like that, and basically solve them. Okay. Now, it's a couple years back, I actually spoke in Altium Live. I think it was 2019. I actually presented there what was called the 5 pillars of your library. And I used an acronym called SMART. And for each one of these, now understand, I've seen a lot of libraries. I've seen, oh my goodness, I've seen hundreds and hundreds of libraries, and in consulting, helping companies set them up, being a part of that and things like that. And even though every single library was unique in some way, there were these 5 pillars that were a part of every single library that I saw. Keep in mind with pillars, and I kind of use pillars just because it's a kind of a structural thing. It actually supports the building and things like that in architecture, but in the pillars, if I took one pillar out, then what happens is the other pillars have to compensate for that. Now, that's my first point here, is that each one of these 5 pillars are necessary. Now, I'm not going to be able to go through in detail all the 5, and I would really recommend for you to go back and kind of review those presentations. They are on YouTube at the Altium Academy, to kind of re-listen to them and find out in more detail these 5 pillars. And these are singularity, managed, architecture, review, reproducibility, and then traceability. Now, I'm not going to, like I said, I'm not going to be able to go through all these, but there is one that I want to talk about, and that is singularity. Because I find that a lot of times this is kind of the underlying root cause of issues and problems in libraries. Now, nothing causes problems faster than having multiple libraries to work from. This is a situation where you might find yourself constantly having issues or problems, and it's basically you're trying to work from multiple sources of information. And what you need to do is have that single source of truth. Now, those of you who are familiar with me are or know my story. I actually worked for a company several years ago that had issues and massive problems in fabrication and assembly of their PCBs. And when I looked at it and kind of investigated, it was because they were working from multiple libraries. Actually, they were working from over 1,100 libraries, and which was unbelievable. And one of the first things we had to do there was get a single source of truth to basically consolidate those libraries. Well, for me, it was better for us to simply delete them, and that's what I did. I actually went in one Friday night, deleted all the libraries, and basically started over. So that's the real key here, is that the challenges that you have, and this is having multiple libraries, trying to organize a good PCB design from multiple information is very, I would even say it's impossible, okay? It is very, this is your first challenge that you need to take up. And before you put in place the other four pillars in your library, make sure this is the first one you take care of. And this is the first challenge, is having that single source of truth. Okay, and this is really where it's going to come down to brass tacks here when we say that. Now, fortunately, Altium does have a fantastic solution for you. We have Altium 365 that allows you to first off consolidate your library, and we're going to see the tool called the Library Migrator here in a bit. And what is nice about this is that you will now be able to consolidate the libraries into a single location for all your team to work with, which is really great, because now after that singularity, what was the second pillar? Managed. Then you can actually manage your library, get it organized, and then you can take the steps that you need to do to make sure that you have good quality there. And that's the main key here. And that's what we're really looking for, not just in this presentation, but also in your library, is to have a quality library. Okay. So in Altium 365, you're going to be able to consolidate those, have them in a central location, to where people are actually able to work from that. All of them will be able to work from that single source of truth. Okay. So Altium 365, and this is a view of that library. For example, you've got your components over here, and what's nice about this is also ties you into Octopart, IHS market, and a custom database. Now, just take note here, the IHS market and your custom database is a pro feature, okay? So just so that you're aware of that. This here then is your library structure, and this would be available to any team members that you invite into the workspace. And one of the tools that I like the best here in Altium 365 is the Library Health Monitor. This will actually monitor your library, see how healthy it is, see what issues are there and what problems that may be occurring, okay? Just so, because what is important here is that once you begin to consolidate that library, you need to then look at the health of that library and keep it healthy. The library, another point is this in regarding your library, before I move on, is your library, there is no finish line for your completion of your library, all right? There is no finish, there is no line that you cross and break the ribbon or anything like that. And what is important with that is that a lot of times we look at the library as a linear process, being that we start a component and we then take it down and we then sort of like we kind of label it as finished, but really it's never finished, because what happens here, and we're going to see this more here in a bit, is that there is both static and dynamic information now in that component. And because of the dynamic information, what happens is there's constant refreshing, and there's constant improvements that you can make on the library, okay? So keep this in mind. Um, excuse me. So keep that in mind. And what you're able to do is actually begin to improve your library through the health monitor. And instead of being a linear process, it's actually more of a circle. All right. So as you go along, there's improvements, there's changes, and then you kind of loop it back where you're always constantly improving and polishing that library. Okay. So let's move on here. And when I was in high school, one of the classes that I had the biggest problem with was biology class. I did not like biology class. It was not something I was looking forward to. And it was mostly because of the fact that there would be the dissection of the frog. Okay, we've all probably experienced this, right? The infamous dissection of the frog day. Okay, and there are so many bad experiences that I had with every single year of having this issue with going through biology class and dissecting a frog. Okay, but something I did learn through biology class was that every organ, and I guess this goes for us too as human beings, every organ that we have, our makeup, there is a purpose for every single organ and every single part of our body. And that was something that I actually learned, was that each part has a purpose. And that's my point here, is that every single part. Now, if I took a component and I put it down on the cutting board, we'll say, and I would dissect the component, what would I find? And what we would do is we'd actually see that, first off, Octopart has about 20 million components if you go there right now. There's also another site that Altium works with, IHS Market, which is a part of the A365 Pro platform. They have over 900 million components. Now, that's a lot of components. All right, let's be honest. But what is common about that is the fact that every single one of those components is unique in some way or something like that. Their makeup is the same. Okay, if you dissected that component, we would see the same individual parts in it. First off, you would actually have information. In that information, you have a name, a description, the parametric information, the sourcing, and the data sheet. Now, a little word about the data sheet. The data sheet may not be correct, but it's there, okay? And so, yeah, I mean, keep in mind that not all data sheets are to be trusted, okay? Now, the other side of that is your models, which is really, really a part of this, okay? Now, as a makeup of an electronic component, you're going to have a schematic symbol, you're going to have a footprint, a 3D model, 3D step model embedded in the footprint itself, and then also simulation. Now, the only one item here that I would give a little bit of flexibility on would be a simulation, okay? The entire industry is getting better right now with simulations and providing simulations. And they are now available a lot more. When early years when I started, simulations were almost impossible to find, except for generic, discrete components, things like that. The ICs were, because of the proprietary part of that, were very difficult to find. Manufacturers are becoming a lot better with sharing that information now. Okay, now the point here is that everything has a purpose, right? Every one of these items has a purpose behind it. And what happened if you looked at your design process and the flow of that process, you're going to have different roles involved, all right? You're going to have the PCB designer, maybe an electronic engineer, a mechanical engineer, component librarian if your company's lucky, third parties, procurement, all these people. Now, a little word here about involving those. I did talk about Altium 365 a little bit a moment ago, and I can tell you that another big focus of Altium 365 is the collaboration of your team, not just internally but externally. All right, and not just the people inside your team, but also people that may be outside with fabrication, assembly, and so on. And that is really key here. Also, is that uh, we're now looking at the fact that these components have a breakdown, all right, a part of it, and each of those have a purpose. Now, each one of these pieces, we'll say, of this component are used at different places in the design process, which is really, really good. Now we can identify the role of who is involved in this process, and we can also define what item in this component they're going to be looking for or looking at. So let me give you an example. You may have an electronic engineer that will be looking at your parameter information. He may be looking at sourcing or data sheets, things like that. The PCB designer, he's concerned with the symbol, footprint, 3D model. Another great example is your mechanical engineer. He's not going to be as concerned about the footprint on the board as he is the 3D step model, for example. The procurement, what are they concerned about? Well, are they actually concerned about the schematic symbol on the schematic itself? No, they're actually concerned about the part choices that are made, their sourcing of that component. So my point here is that if you begin to look at each part of this component and the breakdown of the component and where they go, you're going to have a much better understanding here of the anatomy of the electronic component and where it's going to go. All right, and who's going to be looking at this information and who's going to be needing it. Now, I find that a lot of times, if our first challenge was the fact that we don't have single libraries, I think a second challenge here that we have is the fact that we don't have completed components in our library. This is really important because I find that a lot of times, as the process goes through in the PCB design, a lot of times what happens is the procurement people come up and they look at it, and it turns out, nope, that information is not there. It's not available. Now this causes several different problems, but the biggest thing is that it slows down the design process. All right. Now this is really important because I think a lot of us are experiencing right now the issues with time to market, things like that, things that we are looking at trying to get things out to our customers faster, different things. If there's anything that's missing from this component and someone has to come back to you to ask for it or different things like that, that's always something that slows it down. All right. So I would actually say that every single one of these parts or pieces of the component are necessary and are required. Like I said, the only thing that I would maybe have a little bit of flexibility on would be the simulation. All right. But if your company is looking at doing simulations, then you need to really concentrate on that area. Okay. So this is really the anatomy of the component, how it's broken down, and who is going to be looking at this information and requiring it during the design process. Okay. So now that we've looked at where this information is going to go, what information is going to be put there, we can now start looking at how we're going to load up our library. And the very first method that I'm going to talk about is actually the library migrator. This will migrate your components that you're already using into a consolidated location. Like I said, I would really, really recommend for you to look at Altium 365. It's a part of your Altium platform. It's ready to use right now, and it's a very good tool. Now, just a little side point here. Probably a question is about security questions and things like that. Keep in mind that you can put into into Altium 365 your components and have your projects on your local server. That's perfectly okay. All right. So let's look at how we would begin to migrate and consolidate our libraries together, and see some really special tools that we've got available here with the Library Migrator. Okay, now, first off, this will actually work with integrated libraries, Schematic lib, PCB lib, SVN lib. All right, and you can actually then migrate these in. You get to the Library Migrator through File and Library Migrator, and this panel will actually open up for you. Now, what you do is you actually add the library here, and it will actually list out your library first off for you. Now, what's nice about this is Altium, the Library Migrator will actually identify by your default designator where it's going to go. So it actually can identify your resistors and then look at your default folder and different things like that. So keep that in mind, that you do have to keep, if you have designators that may not be absolutely correct, that they may end up not being able to be identified, and they will be put into a uncategorized folder. Okay, just kind of keep that in mind, and we're going to kind of look at this in more detail here in a second. But over here in your panels and properties, you actually have some really, really good tools to use. First off, you've got your parametric mapping. That you are, what's happening here is you're actually looking at one library, and you're looking at two libraries actually. Your source library, and then your basically what will be your final location of your single source of truth. Okay. These two libraries, you're actually kind of merging them together. Now, there's most likely they're not the same in some way, okay? So what this parameter mapping allows you to do is to map your parameters together and to actually kind of merge them, all right? And to kind of meld them together. So this is really, really a great tool. Now, you also then have part choice mapping. Now, what this will do is actually identify the manufacturing information, the manufacturing parameter that you're using, and what your part number parameter will be in your source library. Okay. So also then you have some migration checks, which is great. Now a little. Remember, as I said before, there's no real finish line here to your library, right? So it may not be perfect. The libraries that you are migrating in may not be perfect, and that's perfectly okay. Now, I find that a lot of times people want to kind of polish them and clean them up beforehand, and then they'll do the migration. I think you can only take that so far, all right, in a suggestion, as far as you need to understand that there needs to be a kind of a line that you draw and say, okay, we can't keep polishing this. We need to go ahead and migrate it, and then we'll do the polishing on the other side. So kind of do that evaluation and determine where that line is for you and your company, and then take those steps to migrate your library. Okay, it's going to be really, really important. But you do have some migration checks that that you will do on your project, which is really great. Because what this will then do is this actually will help you clean the library up before you migrate it in. It's not going to be like a teenager that you tell them to clean up their room, and what do? They push it from one side of the room to the other, right? We don't want to do that here with our libraries. We don't want to just pull in and push junk that we know that is bad into our new library, okay? So these are some great checks, and the way that you run these is actually you hit the validate button to run those checks, and what occurs is this: it will actually go and run those migrations, and any issues or problems that will come up in the message window here. It will be flagged, and it will come up in your message window. So for example, here it's telling me that the component type is undefined, and if I look and I see there, yep, that's absolutely true, that's none. Now what I can do is actually do a manual repair, we'll call it, of this component and select that as saying, yep, that's a connector, and change the component type. So that problem will then be an issue, will be solved actually. So here, now, I want you to take notice of something, and if you've been working with multiple libraries for any period of time, you're probably going to have the situation of duplicate components. And what's nice about this is that there are 2 checks that are done in your library for duplicate components by parameter or by part choice. And this is nice because then what you can start doing is weeding those out beforehand, and solving that problem. Now, what you are able to do here, if that is the error that comes up, you can actually right click on that error and you can exclude something from a migration, which is great because then you can actually, that will be put onto a secondary list and ignored, okay? So really what you're trying to do here is get through all your problems, issues with your migration checks. Now understand, this library may not be perfect, but you can continue working with it once you can do the migration, and you can go ahead, hit the migrate, and when it is done, it will come up and tell you the migrator is now successfully completed. It will give you a short report here. You could open your log if you needed to, okay? And that is your first tool, is to go ahead and migrate your libraries in and consolidate them using the migration checks and different things like that into a single source of truth. Your single library. Congratulations. This is a huge step, I will tell you. It's unbelievable the impact that just having a single library for everyone to be working from. It will change how your entire outlook of your company. All right, it will definitely do a fantastic improvement, we'll say. I told you before the story about the 1,100 libraries, and we had a massive failures before that. After we took that step of creating then a single library and our single source of truth for the company, we then saw a significant improvement on all our PCB designs, because now we knew exactly where the issue was. If there was a problem, we could easily then identify and go to that location in that single library and be able to fix it. Okay, so that is a really, really important point. And the very first method that you have here is your library migrator, and to migrate these components. Okay. The second method that I'm going to talk about and how to load up your library is through the manufacturing part search. Now, this is a really phenomenal tool. And usually when I'm doing PCB designs, I will actually open up my component library, which is my Altium 365 library, and my manufacturing part search. Because what happens is, if I cannot find the component in my library, then I immediately go over to my manufacturing part search library and I search there. Now, there at the last count, I hate to say numbers here because it constantly changes, but let's just say that this library actually ties you into the Octopart library. There's a lot of components here, a lot. And there's a phenomenal view into the library here. It's got the component category, the family, the subfamilies, in the structure, and that kind of brings up the third pillar, which is your architecture of your library. You want to look at that. And this is a really phenomenal library, I can tell you that. And it is a great resource to you and your company. Now, you can actually get there through this pull down window here, or you can go into the portals here that takes you into the same location. Okay, so you can actually then go into through your specifically looking for the component you're looking at or looking for is through their parameter filtering. And what happens here, let's say I go into my resistors, all the parameter information that is in those components are then filtered out, put onto a list here. And what I'm able to do is actually look and go into my look and put into those filters exactly what I'm looking for. This is really convenient because now these all these components that are available in the manufacturing part search, I can quickly find exactly what I'm looking for. And what's nice about this is I can also put in a range of information here. So if I'm a little bit flexible in my design or different things like that, I can actually put that range from and to, and look at a broader selection there. Okay, so that's your very first thing, your filtering button here. You can actually look at that. Now, what's nice about this is it also then ties in your suppliers, and this is something you want to look at as far as your procurement of the component. And this is all live dynamic data information that you're looking at. Now, keep in mind, sourcing is one of those major areas. We're going to talk more about this here in a bit, but sourcing is one of those major areas that is impacting everybody. Okay, so this is probably one of those challenges that we want to go into deeper, and we will. But when you're doing a part choice or selecting the component, you want to look and see kind of what the pattern is here. This green bar here will change color as the procurement becomes more and more of an issue, we'll say. Okay, so you don't want to, for example, have a component that has no stock or supply. And we're going to look at some solutions for that here in a bit. Okay. Now, just be aware as you're making the choice of your component is to kind of get this component off on the right foot, we'll say. Okay. So, and that's done through this procurement panel. So what's next is that you actually have then some properties and information that you can open up here on this component right here. And which is really nice. First off, it gives you your parameter information here. You can look at the details of that component and determine if that's really what you're looking at. It also then looks at your compliance. There's, look at different parameter information here. There's also then the models that you've got available to you, the schematic symbol, footprint, and so on. There's also then the data sheets, and also then alternates, which is really kind of a very important area right now. And I'm sure, and we're going to look at this more in detail later on. I'm sure you'll know how. Okay. But that is your makeup. And if you notice, if you remember when we went through the anatomy, right, every one of the pieces are here. Okay. Your information, your sourcing, your data sheets, your models, everything is here, okay? And that's why it's so important to have a strong component with all its information, okay? Now, there's a really nice feature here, and what happens is if you hold down the control key and select another component, you can actually do a compare between two components in the in the manufacturing part search window here. Okay, now now that you've found the component that you're looking for, there are a couple options for you. You could place a component directly into your design. Now, there are several disadvantages of doing that. Okay, and let's talk about that for a second here. Number one is your component must have a model attached. If you're going to place this component directly into your design, you need to have a model with it, and that can be told here by this little green icon of the IC. Now understand, not every component in the manufacturing part search, I know this may be a shock, but not every component in the manufacturing part search has models. Okay, and we're going to talk about that later on here. But the very first problem you're going to have is that the component must have a model. Okay, another disadvantage is this: it will result in using two libraries. Now, when you place that component, the source of that component will be the manufacturing part search, and you will then be using your library, once again, hopefully in Altium 365 and the manufacturing part search library. Now, because of that, you're kind of breaking the first rule, the first pillar of singularity. Now, the problem is, the biggest problem here is that you can't edit the manufacturing part search library. It's a read-only. That's Altium's library, and you can't edit it. So that's probably the deal killer here on using a manufacturing part search. But there is another option, okay, with this, okay, and there is actually a better option, and that is to acquire the component. Now, what this will do is move the component from the manufacturing part search into your library, which is really, really convenient. Now you're going to keep the consolidation of the library as a single library, and you're also going to be able to edit those components, okay? Which is really nice. Now, the way you do that is you hit acquire. It's going to first ask you where you're going to be putting this component and what in your location in your library. And then as you do, when you select that and hit OK, it's going to open up then the use component data, that what you want to select and what you want to bring in. Okay, now this is really important because most likely, as you bring new components in and acquire these components from the manufacturing part search area, you may not use the footprint. And that's what I find that kind of drops off this list first, is your footprint. So for example, I'm bringing in, if you're bringing a resistor here and you're going to use a 402, you may already have a footprint for that. You probably do. You should at least. All right. And you can bring that component in. So you may deselect here the footprint that you're going to bring in, because you really want to be careful here not to overlook this. Okay, I really warn you on this, is that not to overlook this step, because what happens here is that if you bring these models in and you say okay and you save off this component, what will happen is you actually will then end up starting to have multiple footprints in your footprint library. And then once you're doing that, you're getting away from what? The singularity of truth, we'll say. All right. So keep this in mind, and this actually is really key here, because you need to know and what footprint you have. Okay. And most likely for most components, we'll say, and most of your library will say is that will be made up of discretes. When you look at the overview of a library, I've actually seen libraries with 50-60% of the components being discretes. And because of that, you may have the situation where you already have the footprint, things like that, and you can bring those in. Now, you will have 3 footprints with each one of these components. You're going to have IPC least, nominal, and max. And then what's also now being added is your manufacturing footprint. Okay, so what I would recommend is to do it this way, in a way of organizing your footprints, is first off, have a library with your golden footprints that will be your IPC. All right. Then have another in that, have the manufacturing footprint for that component. Okay. That way you can actually connect up all 4 of those into a specific component and be able to have a much stronger component because of it. Okay. Now, because of this, it will actually then, when you say OK here, it actually will open up your component for you in the single component edit window. You can take a look at this. You have your 4 footprints here, your parameter information. Now, this is really great because it kind of gives me a great view of each piece of the both information side and the model side here. This here will give me my information, my parameter information, my sourcing, my data sheet, and over here then is my models, my schematic symbol, my footprint, and my 3D model, and I could then add in my simulation here. Okay, so this is how a strong component should look. Okay, from here it's just a matter of saving this. Now, when you save this, I would recommend for you to run your component review on the components, every component. A lot of times I know you're in a rush. It's save it off and be done with it, right? But I want you to make sure to run these component reviews, and that's done through after you save the component, you go ahead and right click and you say run component rules. Any problems or issues that are with that will show up in the message window. Now, what is important about this is that this is the first rule check done in every single PCB design. Okay, get that, understand that, embrace it, love it. Okay, this is the first rule check done in every PCB design. This is where you have the checks of your components and you're making sure they are done correctly and that you don't have to stress out, all right, about putting a component down and thinking, okay, is this right or is it not right? All right. I find that that's that's a really important step here when you don't skip over this component review and this check. Okay, this is your very first rule check done on every single PCB design. Okay, now let me go down. Let's go through the third way that you can now load up your library. Okay, now this here would be the manual method. Now, as I mentioned earlier, not every single component has its models. Now, what you are able to do though is you can bring in, by copying the part number, bringing in and starting a new component, as we're going to see here, you can bring in at least the information, the name, the description, the parameter, and the sourcing. That information. A lot of times what happens is there's not the models, okay? So this is where we can actually then begin to use the schematic and PCB wizards, okay? Now, a little word about wizards. Now, there are a lot of wizards in Altium, okay? There's, excuse me, there's a lot of wizards, there's a lot of tools that are involved, and just a word about wizards. Now, what you're looking at here is a 1976 Datsun B210, okay? Cool car, right? It's an old car. Now, this is actually the car that I learned to drive on. Back in the back hills of back in the back hills of Pennsylvania, I learned to drive on this vehicle, this car. Now, it's a stick shift. Now, with that, I was able to, it took a while to learn that, clutch. Let's see, you had the clutch, the gear, and then you had to push the clutch in and shift the gear and let out on the clutch while you're pushing down on the gas, right? It was a maneuvering, okay? Now, the thing is though, when I moved over to an automatic, that was simple compared to the stick, okay? You just shift gears and push the gas, right? Now, my point here is this, is that don't get lost in the wizards of automation or the automatic process here and not know how to do it manually, okay? When I learned on a stick, it was very easy for me to switch over to an automatic, and then I could actually switch between the two of them very easily. But I knew how to drive the stick manually, all right? And what is important when you're looking at a wizard, I find that a lot of times with designers and different things like that, they like the wizards and just hit next. Okay, and we're done, all right? But they don't understand the process of what they're doing, all right, through that wizard. And we're going to go a little bit more detail here in a second on that. So just keep this in mind that the wizards are good and use them, but learn how to do this manually also. Know what's happening in those wizards and know why those wizards run the way they do. Okay? So with that, let's look at then the third way of manually creating a component. And like I said, a lot of times you'll have this side, the information side of your component come in, no problems, no issue, but your models are lacking. Okay, if you actually look at the manufacturing parts search, one of the parameters that are available there is give me my components that have no models. And you'll see that there are thousands and thousands of components with no models. Now we are working on improving that process, okay, improving loading up that library with models and different things like that, just so you're aware. But if you come across the component that you have, first off, let's say your schematic, you do have the option of using an existing or building it from scratch. Now, I don't have the time in this presentation to go through in detail all the steps involved with creating a component manually with drawing lines and in the schematic symbol and so on. But like I said, take the time to learn that. It's really, really important and vital to learn those processes. Now, the one thing that you do have here is the wizard. And what you're able to do then is select that. And what's nice about this is you can actually open up then the schematic wizard. Okay. Now, the very first area here it's going to ask you is how many pins you're having on your schematic symbol. Now, this is all from your data sheet, of course. You can have these layouts that are in your schematic symbol, whether it's quad or whether it's single inline connector and so on. And what you're able to do is do a smart paste. Now, what is nice about the smart paste is you can actually go into the data sheet. If you go into the data sheet, there's an area called the signal descriptions. And this will actually then give you the symbol, the name of the display name, would be the display name here. And what you're able to do is you actually copy and paste that information directly into the symbol wizard itself. Okay, so it's not like you have to sit here and type all this information. There is the smart paste that you can use to lay this information into this schematics, this symbol wizard. Okay, so just keep that in mind, the smart paste. All right. Now with that then, you can also then set up your electrical types, different things like that. You can do the description, the sides of what the sides are. You can do groupings. This is a really, really powerful tool, and it's really nice. And it will definitely save you a lot of time, especially if you're doing, 100 pin components, things like that, maybe a BGA or an FPGA or stuff like that. This will actually save you lots and lots of times with this, and be able to quickly get through and create your symbol. Now with that then, let's look at our footprint side. Same thing. And the thing is, like I mentioned before, you may find that as your library grows and improves, your footprints will also will start being repeated a lot. Okay, so just keep that in mind. Is that you will have your footprint wizard, but then the very first step here is understand you need to do a search of your footprints. Make sure you don't already have them. Okay. And this is really, really important. You want to try to stay away from duplicate footprints, symbols, components, everything. Okay. So in the footprint wizard for the footprint, you can then go ahead. This is going to be the ICP compliant footprint wizard. And this is all, once again, going to be the very first decision that you have to make here is what type of footprint it is. Okay. Now, this is really nice, and this actually will begin to help you understand the breakdown of components and the breakdown of the footprints. I have actually seen footprint libraries that have this structure of the breakdown of the type of component, all right? And this is really nice because you're actually then able to organize your footprints, let's say, into your chips, into your TSOPs, or whatever they may be, okay? So this is really nice, and this is a good information here. So this is, of course, is going to be based on your data sheet itself. So if I was looking here at this TSOP, I would actually look at this, and I would look at the dimensions of this and transfer that information here, okay? Now, you have your max, your min, and things like that. And as you're doing this, you can actually, it will actually then begin to build the footprint for this component on this information. Now, what you're able to also do is you transfer that information in here. You also are able to generate a 3D step model. And this is really important because you want to make sure to embed your 3D step model into your footprint. Why? Well, that's going to go over to your mechanical person. He's going to be looking at that and making sure, for example, that as the 3D step files that you have on your PCB goes into the case and there's no interferences, right? So keep that all in mind. So here you actually then get more into the automation process. You can put a thermal pad on this component, and whether there is a pad or not. Now, what's nice about this is then a lot of this is where people who like the wizards start hitting OK, right? Next, next, next. Okay, yeah, just ignore this part of it. Now, you notice here it's doing a measurement. I'll give you an example of this thing about manual versus automated processes. You notice here that it's doing a measurement from the heel, what would be the heel of the lead to heel. Now, why is that so important? Well, what is important is the amount of pad that goes underneath the component to support the heel. That's where the most stress is on the component, okay? And what is needed is to make sure that you have a good solder fillet on the inside underneath the component to be able to support the part itself, okay? So this is an example of that, of having the information, of understanding what this is doing, okay? And why it's so important to look at this and say, oh, okay, yeah, I understand what's going on here. So then this here is another great example, all right? The calculations that are done for the toe area and the side of the lead, all right? To make sure that when you get the solder paste down on the copper, that there is enough solder to create a good solder fillet up the lead and on the toe. Now you've got the heel and you got that lead really well supported. Now this also then is where you would then create, for example, your 3 levels of your IPC of your nominal, least, and max. Okay. Now a part of this then is that you have your tolerances. You have then also your IPC tolerances here again. You have your footprint dimensions that a lot of times are put into a mechanical layer on the footprint. Now this is a really nice area. I mean, this is going deep into the footprint itself, and this is something that you should study. All right, look and understand the footprint and what each one of these pieces does, and what that footprint should look like. If I going back to my dissection analogy earlier, if I was to take the footprint and I would then dissect that and go deeper into it, this is what we would be seeing here. Okay, so then you have the silkscreen dimensions. You have then the body information, which is going to include your courtyard. It's going to include your assembly information and your body information. Okay. So with that then, it's going to give it a great name, an IPC certified name of that component, and a description. Now, this is really important to understand also, is that what you're naming things in your library is really vital and important. You may have your own naming convention, and you need to make sure that everybody else understands that convention, whatever it is, right? But I would actually look into your IPC and begin to name your components, your schematic symbol, footprints, and all that in an IPC certified way. Okay, so with that then, you're actually now finished. And that component then is added, that footprint is added to your component. Now you actually can go ahead, you had your information before when you first started this component, you have your symbol and your footprint, you can now save it off. And then what do? Run your checks, run your component checks, and run that very first check in your PCB design with checking that component, making sure it is correct, okay? Now, a little word here about your components. A lot of times, components are created and they're used automatically. And we kind of use our PCB design process, or our more importantly, our fabrication process, to test these components. Now, what is important here is that a rule here would be this, is do not use a brand new component on a new design that has not been checked. All right? So when you create a new component, that component needs to be quarantined, set aside, checked, and then it can be used after it's been verified. Now, I've seen different levels of checks that have been done by companies and people. Is number one is they have a level where first level would be where they check the component to the data sheet, IPC standards, or things like that. They then also have another level called prototyping where they will take that component and put it on a real board, and they'll then see how well it performed through the assembly process. Okay, so the point is this: is that have a good QC process in place, that you're not using unchecked components in your designs. A really, really important point there is that that's going to save you so many headaches and things that you don't just assume things and push it into your design and try it out. We'll say, okay. So have that good QC process. There is a setting in Altium, by the way, with the life cycles that you're able actually to check with a certain life cycle, is to check that where that component cannot be used in a specific design. Okay. And what that will do is if you do use a component that's not checked or is in a certain life cycle state, it will come up with an error message on the ERC and DRCs and so on. Okay. So just keep that in mind, and as a part of the kind of full package here is that you do have the creation of your component and the QC process. Now, let's put this all together. Let's look at how do we then, we've looked at our library, where it's going to go, Altium 365, what we're doing, what is being created, and how to do that. Okay, we've seen three methods on doing it. We can use the library migrator. We can then go ahead and use the manufacturing part searcher with the acquire feature. We can also then build the component manually and from scratch. Okay, so how do we then begin to cope with design challenges? Now, the fact is this: every design, every situation is going to have design challenges. Okay. So what is important is to understand is to first off, we must identify the root cause of the problem. All right. A lot of times we don't work and we don't look at the way I should say this is what we deal with as far as things that we look at as challenges are just is the fringe issues, we'll call them. All right, they're not really the root cause of the problem, and a lot of times, if you don't take those additional steps to get down into the root cause of a problem, a lot of times you never solve the issue. Okay, I'll give you a great example of, first off, a way of finding the root cause is there's a little process called the 5 whys. There's other systems that you can use, but 5 whys, for example, is you keep asking why something is happening. Okay, so for example, if I came out to my car and I had a dead battery, my first why is this: why is my battery dead? Oh, okay. I found that the cause of my battery was a loose belt on my alternator. Okay, now let's take a step back here for a second. If I was in a hurry or something like that, I might be the fact that I might just pull my battery out and put a new one in, right? I've done that actually. And it will never solve the problem, okay? Because the first why is my battery dead? I have a loose cable on my alternator that's not charging the battery, okay? That's my second why. Why do I have a loose cable? Well, my cable has been frayed and it's old. Okay, and you keep going deeper and deeper. You can say, well, why is my cable old? Well, I've gone past my maintenance my maintenance schedule for fixing my car. Okay, so when you begin to face a solution of the problem, you don't start at the top. You start at the bottom then of this chain that you have created. And in that root cause, that's where you then start solving the problem, okay? So let's kind of do a review here. We had the anatomy of our electronic components. The solutions are found in each one of these library items, and that's a really important point here. Is that every problem, I won't say every problem, the issues and challenges that you have in the PCB design process, and this is the whole point of this presentation. Okay, the challenges that you have as a PCB designer are found in these library items. Okay, and you need to begin to look at that in that way. I'll give you a great example. For example, if I had mechanical problems in my board, if I got emails or call, my mechanical person told me, oh, by the way, we're having issues in mechanical fitting this into the case, for example. Well, what would I be looking at? Would I might look at the data sheet, for example, as for the source of my information, but also I would look at the 3D step model, okay? And I would then begin to look at what is the root cause of the problem in my 3D step model. And this is a part of that process of polishing your library and constantly keep improving it, because as you go through the challenges of the design process, you now have an intelligent library to work from. You have good information, single source of truth, good information, good structured components, things like this. And you're now able to begin to look at that information and how to improve it, okay? There are libraries that I have worked with for years and years, constantly keep improving it, polishing it, things like that. And this is really, really important. For example, another problem might be assembly problems. Let's say your assembly house is coming back to, oh, by the way, we're having tombstoning on some of your components, right? So what would you be looking at here? Think about, okay, what would be item in my component would I be looking at? Well, that would be the footprint, okay? Then, more specifically, as you're going into that footprint, look at the details of the structure of your pad, for example. And does it have the correct structure or the correct information to have a solid component footprint? Okay. Another issue would be design specifications, for example, whether that would involve your data sheet, your parameters, things like that, okay? My point is that when you look at the challenges, you begin to look at the root causes, identify where in my component does this information lie, okay? That is really, really going to be an important step here. Now, let's go through. Each one of us is probably having the experience right now with part shortages and procurement. And this is something I wanted to take a little bit more information on now that we understand how to use the information, how to identify root causes, things like that. Let's look at this problem of part shortages and procurement. It's something that's hitting every one of us, and it's hitting us hard, right? I have heard some of the worst horror stories. Now, what is funny, and I hate to use the word funny because there's nothing funny about this whole experience, right? Nothing funny about it at all. But what is interesting about this is that these are subjects that we were talking about 2 years ago. These were subjects that part procurement has been an issue for many years now. It's gotten worse now in the past year, I would say, with the component shortages hitting, then the supply chain issues, things like that. And we could spend an entire day on just that, but it's getting worse and worse. So keep in mind that the quality of your part choices determine how well you cope with the part shortage problem. Your part choices and how you've got your components set up in the way of part choices is really going to be how well you kind of maneuver through this whole thing, okay? I find that a lot of times people that this is one of those areas of the component that is lacking the most, we'll say. Now there are actually two things in Altium that are going to be that I would recommend for you to tie into, we'll say. The first one is your active BOM, tying into that, and then the other tool is your manufacturing part search, which we have looked at. Okay, now between the two of these platforms, you can actually then begin to look at the procurement area. Now, the way this is done is that we did talk about the supply chain, different things like that, but then your first notice that there is a problem will occur in active BOM. Now, for some reason, I have seen designers that do not use active BOM, and I'm shocked. I'm actually shocked by that. Here is a really phenomenal tool to use, and they don't use it. It's specifically set up for part short, not specifically, I should say, but it's one of those tools that will help you with this part shortage problem right now. Okay, so if you're not using active BOM, do so. Okay, and use your manufacturing part search. Now, between the two of these, what happens is that you will first get your first warnings about availability. First off, initial availability, we'll call it, on a component. It will tell you that this supplier does not have stock available for a specific component. Then also, it will also give you the first warnings of component deprecation, component dying off, things like that. Now with that, that's a whole another conversation also, is that with these two platforms, the active BOM, because it is working with dynamic information, will give you the information you need, and then with the manufacturing part search, you can then look at sourcing of other components and things like that. Now, most of your components, as I mentioned earlier, will be discretes in your library, okay? 50-60% probably. Now, discrete components have probably the biggest problem then, just because of the number of components involved, all right, that they most likely will have the biggest problem with procurement. That's something that I've seen change a lot. It's who I select as my manufacturer, vendors, things like that, are constantly changing, probably on a weekly basis. Okay, so there's a lot of fluidity with the whole part with discrete components specifically. So the solution for that would be this: have at least a minimum of 5 part choices for each discrete. All right. Now, what you're able to do with that through the part choices is to map out your preferred vendors and preferred vendors and such. Okay, so you're actually able to rank them based on who your first and second choices are, and so on. All right, use active BOM to identify your problems. Like I said, if you're not using active BOM, do so. It's a phenomenal tool. Connect alternate components to your part choices. Now, a little question here. Remember, we had that with our manufacturing part search. We can actually use the manufacturing part search for the alternate selection. Okay, so you actually can see the alternates that are available for that component. Now, keep in mind, this is not a set rule here regarding this. Not every component will have the alternates set up. So there's still a little bit of work there that probably your procurement team will have to do and work on that. Now, little word here about multiple part choices versus alternate components. I find I find that a lot of times we use those interchangeably. I don't see them as the same thing. First off, multiple part choices are exact components, maybe from a different vendor, manufacturer, and things like that, that are exact components, all right, based on parameters or different things like that. Now, alternate components may be ones that are not exactly the same, but they will still work. Now, this is a really key here when we're talking about dealing with the part procurement issues and getting good parts here, is broadening your net, we'll say. is giving you more options. Now, I would add in those multiple part choices as exact drop-in replacements. And then I would also then add in alternate components that may be different in some way. Now, a lot of times, I'll give you an example. A lot of times, tolerances are played around with components. In the being that, let's say I'm using a 5%, I could then go down to a 1% or so on. I don't think I would go the other direction, okay? You want to understand with each one of the parameters of the component that they have a direction that they can go, all right? They could be and to make a change on that component will have an impact on your design, either positively or negatively, okay? So kind of keep this in mind. This is something where you want to keep the options open and as much availability of components for you, okay? So this really want to look at facing these challenges head on. And with that said, I want to go ahead and conclude, and I want to tell you a story. There was a young gentleman who was walking through a meadow one time, and he came across a butterfly that was in the cocoon, and he could see that it was starting to break out of the cocoon. And he actually stood there and he watched this for the longest time, and he saw where the butterfly would stop for a while, and then he would take it back up again, trying to break out of this cocoon. And it turned out that after a while, actually, it stopped moving, and he thought, "Oh my goodness, it's like too much for him." So what the guy did was he actually opened up the cocoon a little bit for him to help the butterfly, supposedly. Now, with that though, what happened is that with that the butterfly came out, but his body was really, really swollen, and the wings were withered. All right, and the point of this story is that it's actually in biology, going back to my biology, right? In biology, it's the struggle for the butterfly to get out of the cocoon is where that transfer of fluids are pushed from his body into the wings. And because of that, he then has the wings to fly. Now, a lot of times we as designers don't like struggles. We don't like challenges. I would recommend for you that sometimes struggles are exactly what we need. Through them is where we become stronger. That's where we actually transform ourselves as designers, not into a butterfly with a swollen body and withered wings. It's where we learn to fly as a designer, is by facing the challenges. And we've talked a lot today about the challenges that we face as designers and things like that. But I want to encourage you to take the steps to take these challenges head on. You have what it takes. You have what it takes as a designer to be not just a good designer, but a great designer. And I can tell you that by going through the challenges that you will face in the design process, you will be a better designer. Don't try to avoid the problems or avoid issues, okay? Don't try to take the easy way out. Face those problems and issues head on, and believe in yourself to know that you have what it takes to be the butterfly that is healthy and with its wings out flying, okay? And I thank you for your time today. I appreciate your participating in this great event. And I want to thank you and look forward to the few days here of taking time away and learning. But I want to personally thank you and for participating in this presentation. Thank you, and we'll hope to see you in a future presentation. Thank you.